You are now listening to the Big Data Beard. Hey everybody, this is Cory with the Big Data Beard, and we are at the Spark+AI Summit in San Francisco, California, and I'm joined by Reynold, who,
hey, Cory.
You have probably the coolest title of anybody here, co-founder of Databricks and chief architect, is that right?
Yes.
Very cool. And we're about to be joined by a fellow Databricks employee, potentially, maybe not. Michael Armburst is maybe going to join us. We'll see. Are you going to be able to join us? Awesome. We'll do it super fast and easy.
All right, here we go, Michael.
What's up, Michael? How you doing?
Doing good. It's an exciting day.
This is the fun of a conference, right? You just bounce into things and you're going crazy. Michael, tell us what you do for Databricks.
So I'm the principal engineer. I'm the tech lead for the stream team. We are responsible for structured streaming and Delta Lake.
Excellent. So you guys had some stress this morning. You had to keynote in front of 5,000 people. Be honest, were you nervous?
Oh, I was super nervous.
Let's be honest, you had the hard part, though. You had to do a demo.
Yes.
Which 5,000 people demo.
Yeah, live demos are much harder.
Man.
I'm sort of used to
it
it now,
it
giving
works.
talks.
Yeah, talks are...
It's still very
talks are
stressful, but sort of getting used to it.
Well, congrats.
Demos are much harder.
That's exactly right. So you guys are part of a really exciting company called Databricks. Tell us a little bit about what you're doing for them. I know you're part of the stream team. Tell me your role and what you're doing with Databricks.
I mean, a lot of what I do is actually thinking about what we should be doing next and what are the sort of important technical initiatives we should be building, and help when awesome people like Michael come up with an amazing idea. How do we help sort of create the channel to make that happen?
Very cool. Well, for those that don't know, Databricks is part of the team responsible for Spark. So Spark is an Apache project. Would you mind giving us a little bit of background on your role in Spark and that community and that cool project?
Sure. Actually, both of us were involved with Spark very early on. We came from this lab called the UC Berkeley AmLab where Spark was born. And then we kind of, I think both of us were instrumental in both 1.0 and 2.0 release of Spark. When Databricks started, I became actually even more involved in Spark. Back then I was just a graduate student. I became working full-time on Spark, wrote a lot of code, became sort of number one committer on the project. Sometimes just polishing stuff a lot of other people do, sometimes coming up with more, I would say, ground-up innovations.
Okay. Very cool.
And then I got involved a little bit later when I joined Databricks about 5 years ago.
Okay.
I joined to help write the first version of Spark SQL.
Okay.
So the idea here was, Spark originally had these lower level APIs called RDDs, which were great, super powerful, but you had to be a pretty good programmer to use them. Right. What Spark SQL does is it raises the level of abstraction. It gives you this high-level declarative programming language that you can use in Scala, Java, Python, or even just pure SQL. And then because it's this higher-level declarative thing, Spark actually understands what you're trying to accomplish, and so it can actually do a lot of optimizations under the covers to make your program faster for you.
Very cool. Now, I want to talk about some of the things that you covered in the keynote, and I recognize you have a little bit of a time-sensitive, really like the hard stuff.
No worries.
So we're going to start with you. Tell us a little bit about some of the announcements around Databricks Delta Lake.
Yeah, so, Delta Lake is a project that we've been working on for almost 2 years now. We announced it at Spark Summit in Dublin, about 2 years ago. And it solves a whole class of problems around managing large amounts of data in your data lake. Data lakes are awesome. You can put tons of data in them very easily. And I actually think that data has a lot of value. But because of quality problems, people often can't get that value out of this data. Yeah. And what Delta Lake does, it brings a variety of things to it that allow you to add quality incrementally. And so you get ACID transactions. So what you say happens actually happens completely or not at all.
Right.
It brings schema enforcement. So you actually understand what the shape of the data is. And if data tries to come in that doesn't match that, we kind of say, nope, you need to fix this up. Okay. And then finally, there's this kind of new feature that we demoed this morning that we'll be releasing later this year called expectations, where you can actually go a layer deeper and talk about your domain knowledge, about what correctness means to you. So you can actually say things like, this column is a VIN number, so it needs to be this long and start with a character and have this many numbers in it. You actually put that domain knowledge into the system, and now it will actually automatically do validations both locally and in production.
Okay. So is it purely on the point of ingest, like before we write data to the data lake, you have to enforce this policy? Does Delta Lake have to exist there, or can it exist and operate in environments where many organizations invested in the concept of a data lake and they've been storing up data for years and they've got a couple of petabytes of stuff and they're like, we're really not getting the value out of this thing we thought we would.
Totally.
Is it only for new, or is it for existing as well?
It's absolutely for existing as well. And this is the kind of incremental refinement I was talking about. A pretty common pattern we see is people will start with their existing data lake, which is just a mess of everything. But there's actually a lot of value there. You just need to sift through it. They will ingest it into a bronze delta table, which is just getting it in there, just getting it arranged so you can query it efficiently, but doing very little parsing. You maybe pull out a timestamp, you maybe pull out an event type, but you leave most of it as semi-structured or unstructured data. And then the power of Delta is it integrates deeply with structured streaming in Spark. So you can very easily create refined tables on top of that. So you can then pull out the one particular event type that you care about, apply a lot more structure to it, augment it with joins and other things, and create this like silver table that is now closer to being ready for analytics. And the magic here is what Delta is doing is it's both storing all of this data and making sure it's correct and ACID and all those other things. But because of the integration with streaming, as new data, you can both get this backfill of all the old stuff, and then as new data arrives, it automatically kind of makes it through your cleaning pipeline.
So this is fundamentally shifting people from having to think of things in this like Lambda architecture. Is that fair?
Yeah, that's totally fair.
Okay, because that's one of the things I think that people have struggled with when they think about their pipelines. It's like, hey, I do have these streaming requirements. I need to know like real-time event data, but I also have this batch because I need to have governance and compliance about the data, and I also have data science activities that want to go on. Does this obfuscate that completely?
I think in many cases it does. And really what it comes down to is structured streaming is exactly one's processing. You don't need to have a separate batch pipeline. So most of your kind of standard ETLs that are going on every single day, those can all just be streams. Now, Delta, of course, also supports batch operations. So when you get that GDPR request and you need to go and redact all of the email addresses one time, you can, of course, do that on your Delta Lake as well.
Interesting. So it almost, whenever you talked about the types of extractions and things you can do, it almost sounds like an indexing pipeline, for time series type data. Like, does that a use case for it where you're saying like, hey, you could actually have large amounts of time series data being forced into an index that's maybe more useful for later analytics? Yeah,
that's a good question. So we don't have like traditional secondary indexes, but we do have a couple tricks to quickly locate data that is relevant to your query.
Yeah.
We support kind of standard partitioning, and then Delta makes that partitioning scalable through its scalable transaction log. So even if you have millions of partitions, you can still query quickly. And then in managed Delta Lake, we also have this feature called data skipping, where we basically keep zone maps on each file. So we'll remember min and max statistics for each column. And then when you have queries, we can eliminate many of the files.
Oh, very cool.
Last year at Spark Summit, and Dom Brzezinski, principal engineer at Apple, who runs their InfoSec group, talked about his use case where he dumps a whole bunch of data into Delta. And in his case, he uses this technique to search very quickly on network traces for source IP and destination IP. And in many cases for his queries, he can eliminate 97% of the data as irrelevant before the query even begins.
Well, that's handy.
Yeah, so yeah, exactly. It takes queries from going from hours to minutes. It's just absolutely crazy.
And I noticed you had a lot of customer reference stories up there, and we don't have to go in all detail, but you've shared some numbers. Like, how much data is currently being processed by this technology?
Yeah,
today?
So last month alone, we processed over an exabyte, and that's growing rapidly. That's up 2x.
How much
January.
is exabyte?
And I'll leave, Professor Ali would love to tell you, an exabyte is one with 18 zeros.
That is insane. So 1,000 petabytes.
Yeah.
That's just absolutely insane.
Yeah.
Well, very cool. Now, there were some announcements around some open sourcing of some of the technology in and around Delta. Is that right?
Maybe koalas. Well, so we open source Delta Lake, which is absolutely. That is the core transaction protocol of Delta.
Very cool.
So we're very excited to put that out there. We've seen great adoption internal to Databricks, but we're primarily a cloud service. But we want to run on your laptop when you're writing unit tests and your on-prem HDFS cluster. We think Delta can solve problems in all of these places.
Do you think it runs outside of HDFS and on-prem? Because obviously there's, and even in the cloud, you've got things like S3 protocols, you've got Google Cloud, you've got a bunch of different storage media. Does it give you the ability to abstract and create data lakes across those?
So not necessarily across them, but Delta does have this abstraction called the log store. It's basically our interface to the storage system. We have just a few requirements. We basically need the ability to efficiently list directories and mutual exclusion for the creation of files, but you can implement this on top of any storage system.
Very cool.
Yeah.
Well, it's awesome to hear. I appreciate the updates on Delta, and I want to be respectful of your time to give you time to get back to to your things. But thanks for dropping in.
Yeah, thank you so much.
Spending some time with us.
Nice talking to you.
Cheers.
Thank you, Michael.
And sadly, you'll miss out on the rapid fire, which is really where we got to learn some things about you. But
more interesting person than I am.
That's right. Awesome. Thanks for joining us. So super fun to hear about Delta. There were some other big announcements though that were made this morning. I'd love for you to share with us a little bit about some of the things that you guys said, because one that was exciting was around some of the Spark 3.0 that's coming later this year. Help us understand what that means.
Yeah, absolutely. So Spark 1.0 was released about 5 years ago in 2014. And it was a big deal. It was for the first time we marked to the world, this thing is in production ready and go use it. And Spark 2.0 was released about 2.5 years ago. It was almost a complete rewrite of Spark 1.0. The entire API is different. What Michael talked a lot about, higher level declarative APIs, is what we pushed out in 2.0. But also the entire engine was different. We rewrite the whole thing with like whole stage code generation to get more than 10x performance speed up for a lot of the data workloads. And we've seen some massive adoption. Spark 3.0 is coming this year. I can't pin down exact months yet because of the way of the Apache Software Foundation works. But there's a lot of, if I have the one keyword to describe Spark 3.0, I would say it's ecosystem. It takes a very ecosystem-centric approach to big data, which is Spark is one piece in a very large ecosystem. It is so I would say the growing engine for a lot of different things. So it is at the center, but there's a lot of different sources you want to be able to read the data from. There's a lot of different places you want to be able to run Spark. Hadoop, in the cloud, Kubernetes. And then there's a lot of other tools you want to integrate and run on top of Spark. For example, a lot of them speak standard SQL. Can Spark support standard SQL? So a lot of about Spark 3.0 is providing the right interfaces for the ecosystem. Now Spark should be able to run everywhere, including Kubernetes. Spark should be able to read data everywhere. There's a new data source API that there's a lot of buzz about at this conference, and also want to be able to speak NC SQL. And there's going to be over 1,000 features, so I can't list all of them.
Oh, for sure. No, some of the ones I thought were interesting too. There's we heard from Dr. Patterson, the professor from Berkeley, about how there's changes happen in the computational frameworks, and that Spark is actually implementing some abilities to use things like accelerators and be accelerator aware. What's that? Is that there was a project.
That's part about Project Hydrogen.
Yeah.
So we announced about Project Hydrogen about a year ago at this conference, also in Moscone. And the idea here is we want to bring first-class support to all the distributed machine learning frameworks. That's not just Spark, but also like TensorFlow, PyTorch, and all of this. And to make them run really, really well, there's a few missing pieces. One piece is Spark needs to be able to push data very quickly to all of this framework. So it needs to be a standard way of exchanging data. Second is a lot of this framework can really benefit from accelerators, FPGAs, GPUs, because as David said, that's it for Moore's law.
Yeah,
we're in a post-Moore's
law era. It's
crazy. It's done. Software is no longer just gonna be magically faster every year because hardware gets better. That's it for hardware. So the only way to actually improve performance from a hardware perspective is to leverage purpose-built chips for specific applications. And we'll see I think that will lead to a rise of GPUs and FPGAs even more so than we've seen in the past couple of years. And we really want to make sure Spark is ready for that.
Yeah. You touched on it and spent quite a bit of time, and I want to walk through these because I think you talked about these three like primary principles when you're in your role, as you start to think about how you view the world of evolution that's happening inside of Databricks and inside Apache, projects. How do you make them relevant for customers? You had three key design principles. I'd love to kind of go through those in a bit of detail because I thought that they were they gave me a lot of confidence in where you're going, but they also explained a lot of the reason why you're doing some of the things you're doing.
Yeah, absolutely. So the three principles I talked about, they're not the only principles we follow in this world, but the three in particular I've talked about earlier is one is unified data and AI, and second is to run everywhere. And the third is about creating beautiful, intuitive, and easy to use APIs. And really all three boils down to one goal. It is to make our users, Spark users, data scientists and data engineers more productive in building their data pipelines or data applications. Do you want me to just go into each
for sure. Let's talk about it. So like when you think about unifying data and AI, help me understand some of the ways that you're making that real in the products.
Yeah. So when Spark, I think Spark is very interesting. Let's say 30, 40 years from now, everything is gone, right? All softwares get obsolete. There's a new version of
You mean Skynet has taken over and killed us?
Skynet has taken over. I think Spark will probably remember as it became the first system that pushed for this unification of data and AI. Before Spark, there were big data frameworks that's focused on processing data, like Hadoop. And there were machine learning frameworks that focus on just doing numeric computation. And the two didn't really work with each other.
Right.
But at the end of the day, in order to build complex data pipelines to support AI applications, you need a lot of data to feed into the models.
For sure.
So you really want a single tool or a single framework or a single pipeline that can combine both. And Spark have taken that approach. And that was reflected in the release of MLlib, Spark's distributed machine learning library was packaged as Spark 1.0. We sort of got a bunch of PhDs in machine learning together and implemented a pretty high quality library for that. Now, as David Patterson also pointed out, we are in the era of Moore's law for machine learning.
Yeah.
There's actually more machine learning. It's like 50 or 100 machine learning papers being published every day. No single library could possibly implement all of them.
No.
So we've seen an explosion of machine learning libraries in the past couple of years. So things have changed. In the past, when Spark MLlib was started, we could get a few people together and can implement most of the relevant algorithms. It's not the case anymore. So now people really want to integrate Spark with a gazillion different algorithms out there and a gazillion different frameworks out there.
Yeah.
And they want them to run very well out of the box. And that's what the Project Hydrogen effort is, what we talked about earlier.
Very cool. Now, the second principle was this idea of run everywhere. And I think that's interesting because, you know, we've seen this shift of like cloud computing was going to take over the world, and then the edge was going to eat cloud. And I think the reality is like there's somewhere in the middle, I think, is more true, which is all of it's going to exist for a while. Yeah. So why is run everywhere? How are you taking this concept of run everywhere and putting it into practice for Spark and Databricks?
Yeah, fundamentally, AI data pipelines about data, and we want to be able to, and the easiest way to process data is to process data in place. So we want to be able to run Spark everywhere there's data. Okay. And that is a key principle. Spark initially started with just one mode, which is to run on Mesos. Mm-hmm. A lot of Spark users still do that today. Yep. But very quickly we realized, hey, there's a lot of data on a single laptop, especially for the purpose of testing. Let's make sure Spark runs really well just on a laptop. Right. So we make that happen, and users these days, they could actually run Spark, install it without any configuration, just one line of command, they can run it. Yep. And then Spark Hadoop became sort of the standard data lake on-prem. Yeah. Let's make sure Spark works really well with that. So you can run in Hadoop. And then there's also a lot of environments people didn't want to set up Hadoop because there's a lot of overhead of setting up Hadoop or Mesos. They just want to run Spark to process some data in situ. Mm-hmm. So we created a standalone mode. It's a very lightweight resource manager that runs Spark anywhere you want. Yeah. But now these days, we have seen a massive change in cluster resource management space, very similar to machine learning, that Kubernetes is becoming, if not the standard, one of the standards. Yeah. This massive update. In my talk, I show that there's actually at least twice or maybe triple the amount of search query interest on Google Trends comparing Kubernetes versus Hadoop. Yeah. So the Spark community also saw this trend coming. And about 2 years ago, there's a big collaborative effort that started to add a built-in native Kubernetes runner for Spark. So you could run Spark also anywhere there's Kubernetes. Yeah,
because in one of the 2.0 releases, there started to become like support for Kubernetes, but it wasn't like full, right? It wasn't like full.
There was an experimental support that were added, just like a lot of other features.
I mean, you got to iterate,
Yeah, exactly. And then we have seen sort of the gotchas people have hit. We've seen bugs. We've seen sort of here are the biggest requirements and here are the new needs. Mm-hmm. And a lot of them will be addressed in Spark 3.x. And that's where also I expect Kubernetes support for Spark with GA.
Yeah, that's going to be excellent. Because I hear it in talking with organizations, people that are here at the conference, they're starting to look at that not just for their Spark and machine learning workloads, but Kubernetes as a standard for orchestration in the data center.
Exactly.
That abstraction layer actually being kind of like the gateway drug to hybrid cloud, right? To where they can actually take workloads, make them portable. That's huge.
Exactly. I think Hadoop has taken a little bit, I think Kubernetes has taken a better approach here in that, hey, we want to be able to manage all the cluster resources for all the applications and not just your data analytics application, which is the approach Hadoop Yarn has taken.
Exactly. Fundamentally different. They abstracted this not just for these, but for universal, which is different. It is. Now, you talked also about the easy to use, beautiful API stack. So walk me through kind of the history, because I remember seeing early days when Spark was just entering the space. Like, I mean, this is probably 2013. It was
2013, most likely.
Yeah, it was the whole phrase was, it's faster than Hadoop. Yeah. But then it evolved. So help me understand that evolution and where we are today.
So if there's one thing I spend the most time on, it's actually APIs. I personally spend a lot of time working with users, trying to understand how well does the current API work, what are the gotchas, where in the API it's confusing. Mm-hmm. And Spark initially enters the the market or developer space for two things. One is, hey, it's a new in-memory compute engine that can be 100 times faster than Hadoop, especially for a lot of the iterative algorithms that they implement for machine learning, but also for interactive applications. And the second is, hey, this through sort of a better, higher level language integrated API called RDD, it is substantially easier to write, and which also makes it substantially easier to read than the Hadoop MapReduce API. And we used to show this word count program. They would take 50 lines in Hadoop Java without even adding the import statements. Once you add the import, it becomes 100 lines. Which shows sort of a 50-line program get turned to just a 3-line program in Spark RDDs. So that was a big deal. A lot of users, I think you're right, that they initially came to Spark for the 100x performance improvement, but really stay because of API, because it makes them much more productive.
Come for the performance, stay for the APIs.
I think with a lot of the older generation APIs, people wasn't able to get things to work. And just quoting John Osterhal, one of my favorite professors at Stanford, he said the biggest performance improvement of all time is when things go from not working to working. And I think APIs have that magical power.
Yeah, that's interesting.
If you have easy to use enough API, people could make something to work. If it's too complicated, nobody could figure out how to make it work.
Yeah, it doesn't matter how fast it is.
But we didn't stop there. After so RDD API became very popular, worked with a lot of the users, and then we realized the RDD API is great versus Hadoop MapReduce, but it doesn't have the concept of schema built in. And really a lot of data engineering and data scientists, when we're building data pipelines, somewhere along the way, they have to add structure and schema to the data, even if they started with unstructured data.
Right.
For example, images, they want to featureize it. That means you actually have pixels now and you have a schema. And so they started leveraging the tuple concept in Python and Scala. And then when we look at the typical Spark program back then, so I spent a lot of time debugging Spark programs for our customers early on. They're littered with square brackets and underscores, and for the tuples in Python and Scala. So the program became also pretty difficult to read. And we started thinking about how can we simplify it. At the time, the data frame concept in R and Python were kind of just starting to become popular also. We drew a lot of inspiration from that and created a data frame API in Spark. And that kind of just took off. And a lot of data scientists love it. We saw a huge uptake of not just engineers using it now, but also data scientists who are typically, I would say, taking a less engineering approach to projects, right? Do you want me to talk about koalas now?
Yeah, exactly. That'd be awesome. That would, well, one, because I love koalas. I'm glad you chose koalas as the animal. But yeah, I'd love to hear what is the inspiration behind koalas?
Yeah. So we released the data frame API. I think it was in the first version, experimental support was in March of 2015, and then it became sort of a standard API in Spark 2.0. And as a matter of fact, if you learn Spark these days, you don't learn about the ORDD API anymore. You just learn about data frame. And as a lot of data scientists started using it, we realized a lot of them struggle because virtually every data scientist we have talked to, they learn pandas as the standard for data frame on a single node for small data or medium-sized data. And almost half of them read Wes McKinney's book on Python for data analysis and learn pandas. Half of them learn it from MOOCs, and some of them learn from like the latest university programs in data science. And Spark's data frame API, while inspired by pandas, it's not identical. It's similar, but not identical. And then as a result, all of these data scientists, the more ambitious ones, would try to learn it. And they're like, okay, for this feature, I kind of forget what exactly the syntax is. Let me go look it up. Stack Overflow it. There are some also just refuse to sort of learn a new technology because they've been using the same thing for a few years and it's been working to them.
Exactly.
But when they want to scale to larger amount of data, which happens a lot in production, Spark is the interface. And if they don't learn it, they have to ask some other data engineer to produce a sample downsized data set and give it to them so they can run it on pandas. So we talked to a lot of this, talked to both data engineers that's been doing that service for data scientists. We talked to data scientists that have been trying to use Spark. And a lot of them repeatedly told us, why don't you just make the pandas API work? That would be great.
That would be great. Again, one of those from not working to working would be incredible.
Exactly. So at the end of last year, one of our engineers who also used to be a former data scientist, he came to me and said, I think we can make it work. we should try it. And I was initially a bit skeptical.
Yep.
They showed me a prototype. It's like, hey, I built this over the weekend. Of course, it's not done yet, but this shows you what's possible. And we tested it with some of the data scientists in Databricks, and they loved it. And then we tried with a few customers, asked them, hey, what do you think? Will this help you? All of them, like,
just lights out like this. We have to have this.
Yeah, we have to have this. Give me this yesterday. So we're like, okay, that's serious. Let's get serious. Let's put the real team behind it, and let's build sort of a community. Let's create a new open source project, and let's make this real.
And you're actually releasing this under a pretty permissive Apache license, right?
Both Delta and Koalas are released under Apache license, so anybody could pretty much do anything they want with it.
Very cool. No, that's awesome. So I love hearing the design principles, where Spark and Databricks are going as a company and a project. But I'm curious, you sit in an interesting seat where you've been through universities that are absolutely world class in computer science. You're working in an environment where you're probably getting to talk with some of the most incredible data scientists on the planet. When you look out like the next 12 to 18 months, not just for Databricks, but just as a community, what do you think some of the most necessary innovations are, and where people should really be spending a lot of time innovating to really start to unlock this, like the real AI innovation?
Yeah, I think I do spend a lot of time thinking about all those, but and it's not a problem we can sort of completely solve in the next 12 to 18 months.
Clearly.
Skynet's not going to take over.
Yeah, I'm certain they're already online. They're just hiding.
Yeah,
it's running online. The internet. I'm sure Al Gore invented it.
I spend a lot of time working with customers, understanding what their pain points are, and many of them, I just think the systems these days are still too difficult to use. I fundamentally believe 10 years from now, when we look back, we'll feel like all technologies today are jokes. Yeah. They are so clunky, they're so difficult to use, and it doesn't actually necessitate a fundamental innovation to fix that. I think a lot of it is, hey, for example, dependency management. When you try to install this version of the software, hey, it doesn't work with the other version or the other framework I'm also using, and now I got to fix that. I think having things that are more turnkey will be key.
Yeah.
To
and that's
enabling
not a new
productivity.
problem, though. That dependency management has been biting us in the rear since literally the 80s. Because as soon as you would update, the mainframe OS, you'd break 10 other things in the network. I hope that we solve that one.
Docker is, I think, a step in the right direction in the sense that at least if I don't have within a single project, if I don't have any conflicts, I could just make sure that single project is standalone, self-contained, and I don't have to worry about anything else.
Exactly.
Other than the project.
Yeah.
But dependency is just one example, right? There's a lot of things, like, for example, in Spark itself, there's this concept of degree of parallelism. So spark.sql.shuffle.partitions. It's a config parameter you can tune. I would say among the Databricks support tickets, probably about in the context of performance tuning, about half of them, the answer is, hey, why don't you go change that knob and try a different value, right?
Yeah.
The system should be able to figure it out. There's no fundamental reason why the system can't try it for you.
Do some for you.
And I think that's what the software system needs to get to. Be a little bit smarter. Think about it. And a lot of it is really thinking about it from a user's perspective, what's needed.
Yeah.
The users are not necessarily the people that build the system, understand every intricate detail of how it works. So they don't want to fiddle. They don't even necessarily need the most performant configuration. They just need something to work.
Yeah. That's incredible. So when you look at Databricks and where you guys are going next, in light of some of those innovations, what's the next 12 months for you look like in terms of the things that you're going to be trying to take from thought and put into practice there at Databricks?
Yeah. For us, there are a few different, I would say, intertwined focuses. One is sort of a very important goal for us to build a community around Delta. We believe it's a killer technology that solves a lot of the pain points. Before Delta, I would say, so I love citing support tickets because that's generate real pain points. I would say a third of our Databricks support ticket when it comes to Spark has to do with file not found, or different write and readers modifying the same file and then they conflict with each other, and there are too many small files. As a result, performance is really bad. Delta kind of alleviated all of those, and our customers don't run into those problems anymore. And I think this is a technology that benefits not just Databricks customers, but the entire world. So we'll be spending a lot of effort making that work really well. The other thing is obviously call out itself. We are still very early on in the journey. We have implemented probably like 5% of Pandas APIs. The good thing is most of them are pretty easy to implement. It's just straightforward translation, but it take time to actually draw it up. The other one that we want to focus on, and I'm not going to get into details yet, sort of save for the announcement in the future, is we want to enable sort of the entire ecosystem to work on Databricks. And if you think about the data ecosystem, there's a lot of different things out there. There's proprietary software, there's open source software, there's open source standards. And typically, data scientists, they try whatever they can get their hands on, because whatever gets them the best result, they want to do that. Yep. We have, I think, already make a lot of progress in that respect with what we call a machine learning runtime, which packages basically all the machine learning. Speaking of dependency management problem, we package out all the machine learning frameworks, and they just work out of the box. So you don't have to worry about, hey, for this version of TensorFlow, you need the other thing, and for this version of PyTorch, you need the other dependency. We make sure it works out of the box. Right. But that's just a machine learning framework. There's a lot more in the entire ecosystem they will be working on, and there's some announcement they will be making probably later this year.
Well, very cool. Well, we'll stay tuned. Well, Reynold, it's been fun to talk with you about what was announced today at Databricks and what the ecosystem has to look forward to from Spark. And I love your vision of you're really just trying to make people, these data scientists and data engineers' lives and their jobs more productive. So thank you for joining us. I want to switch gears here.
We've learned a lot from our guests about big data, but now it's time to get a bit personal in a segment we like to call Rapid Fire. Pew pew.
So, Reynold, is there a really great book that you've read recently that you would recommend to us?
This is not a very inspiring answer, but I haven't actually read a book in the last, I would say, year.
Really? Okay.
Before that, I used to read probably a lot back in college and high school, but
probably not
lately, not.
Yeah. So, if you had a song, and I don't remember which song was playing when you walked on, but if you could pick a song, would you pick any particular song to walk onto on stage, like your hype song?
Maybe my wedding song.
Yeah.
1,000-Year Dance, or what's that? My wife's gonna kill me now. I don't remember the exact name of that song.
But you remember you have a wife, so that was good.
I do remember I have a wife.
That's perfect. So, is there a piece of technology that is making your life worse?
Dependency management and build systems.
That's
two collection of technologies.
Nice. Is there personally, what is your biggest money pit? Like, what do you spend your disposable income buying? Like fun things. I'll give you an example. I have a car that I race, and it's
right. The biggest purchase I've ever done was actually a Tesla.
Yeah. Okay. Tesla. Which one did you get?
A Model X.
Pretty cool.
It was a great car. Love Tesla.
Awesome.
I don't agree with everything they do, but I think it's a great company.
Yeah, doing very interesting stuff. I have the exact opposite. I just had a race car that burns gasoline, is polluting the earth every time I drive it. It's the exact opposite. Are you watching any TV shows, like binging on anything lately?
Yeah, I just watched there's a Netflix show, Robot Love Death. I might have gotten the sequence wrong, but it's sort of a mini series of I think 16 or 15 different studios getting together and creating sort of a very small short show, like 10 to 15 minutes for each one episode. They focus on a different topic. It was pretty interesting.
Interesting. All right, we'll check that out. All right, and then final question, what's the next really interesting place you're going sometime?
I'm going to Iceland in May, at the end of May. Yeah.
That's awesome. Are you going for fun, or is it for work?
Going for fun. I don't think there's a lot of
I don't think there's a lot
big data going on there.
People work there, but I don't think there's a lot of big data.
Maybe. Going mostly for fun. Then I'll be visiting our R&D center in Europe, in Amsterdam, and I'll be going to Lausanne in Switzerland for Scala Days. I'll be talking at Scala Days. Almost a months-long trip when everything combined.
That's awesome. Well, have a safe trip. It's been really fun to talk with you, Reynold, about where Spark is going and where the Databricks team is going. We appreciate you joining us on the Big Data Beard.
All right. Thank you. It was fun.
Thanks.
Thanks for listening to the Big Data Beard podcast.
The music from this episode is by Andrew Belle. Check him out on iTunes or Spotify.